So hello everyone, I'm Jennifer Petoff, and today I'll be giving an introduction to site reliability engineering as it's practiced at Google. A quick poll of the audience. So who here is already familiar with SRE? Okay, fair number of folks. Who here considers themselves a practicing site reliability engineer? Fewer folks, okay. So for those of you who are less familiar with SRE, this talk will hopefully provide a good overview of the principles, practices, and cultural elements of SRE. For those of you who are already familiar, much like DevOps, SRE can mean different things to different people. So hopefully there's some stuff up here that resonates with you, and if there are things you do differently in your world, love to have a dialogue about that, and we can learn from each other. All right, so why am I up here speaking today? So just a few facts about me. I've been at Google for 11 years now. Another yank up here on stage, like what are the odds, 2 in a row? However, I have been based in Dublin for the past 8 years. I'm a senior program manager on the SRE team and have been for the past 5 years or so. So I lead the SRE education program at Google, and I'm one of the co-editors of the original SRE book that we published back in 2016. Yeah, and you can find me on Twitter at JenSki if you'd like to follow along. A couple fun facts. My nickname is actually Dr. J, and that's because I have a PhD in chemistry. I also love to travel, and I'm a part-time travel blogger at Sidewalk Safari. So if anybody wants to chat about that in the hallway track, just a few fun hooks there. Oh, problem is the microphone is here, so all right. Trying to make sure that the captioning folks can hear me. Is it any better? Any better? Do you have the handheld mic? Because I can use the handheld and then aim my voice at you a little better. All right, we'll go karaoke style. We'll make it work. All right, so in this talk, we're going to cover what is SRE, some key principles of site reliability engineering, the practices of SRE, and just a little bit at the end on how to get started. So what is SRE? So I'll actually start by talking about the core problem that SRE tries to solve, and we'll talk a little bit about the high-level organizational structures that actually facilitate the practice of SRE. So it can be useful to actually talk for a moment about the operational cost of software and the long-term costs associated with developing software. So in general, software engineering as a discipline really focuses on designing and building rather than on operating and maintaining software, despite the fact that perhaps up to 90% of the cost of a piece of software is incurred after launch. And in a lot of organizations, this means that the focus is on hiring great developers, and operations can be an afterthought. And so running the software is someone else's problem, and this is not a great situation to be in. So in what this means is that the incentives really aren't aligned. You've got developers who want to run fast, they want to launch things, they want to be as agile as possible, and then, hey, throwing this over the wall to the operators who are tasked with running the software and who are responsible for scalability, reliability, and maintenance of that software. So again, this is a pretty terrible setup, not designed for harmony. It's pretty brittle and doesn't scale well. So let's talk about some of the techniques that we can use for dealing with this and reducing product lifecycle friction. So in terms of breaking down silos between the business and development, Agile really solves for this, and to some extent. And then if you look at the bridge between development and operations, DevOps also, the goal is to break down the silos between those two boxes. DevOps actually came around the same time as SRE. Site reliability engineering actually predates DevOps by about 10 years, but it was only in 2016 that we started talking about it externally. But both actually try and solve the problem of how do you resolve that tension between development and operations to achieve better reliability and agility. Okay, so depending on who you talk to, the definition of DevOps might, oh, look, we're got a lot of action happening here. No, all good. So depending on who you talk to, you'll get a different definition of what DevOps actually is. For purposes of this discussion, we consider DevOps a set of practices, guidelines, and culture designed to break down silos in IT development, operations, architecture, networking, and security. And then the 5 key areas of focus of DevOps is to reduce organizational silos, accept failure as normal. Things are going to go wrong, it's just a matter of when. Implementing gradual changes, leveraging tooling and automation, and measuring, this culture of measuring everything. So now let's talk a little bit about the site reliability engineering approach to operations. So one of the key elements here is to use data to guide decision-making and take some of the emotion out of decision-making. We also treat operations like a software engineering problem. So we tend to hire people who are motivated and capable of writing automation. My boss was actually quoted in the Irish Times as saying, Google hires lazy engineers. Like, we're looking at people that don't want to do the same thing over and over again. They want to automate themselves out of a job, using software to accomplish tasks that would normally be done by sysadmins. And the other thing that SRE focuses on is really designing more reliable and operable service architecture from the very start. And in terms of what SRE teams do, so there's really this focus on developing solutions to design, build, and run large-scale systems. We want to do it scalably, we want to do it reliably, and we want to do it efficiently. We operate at this interface between software engineering and systems engineering, so guiding system architecture. SRE, we consider SRE a job function, a mindset, and it's actually a set of engineering approaches to running better production systems. And we like to describe SREs as, being constructive pessimists. So we hope for the best, but we recognize that hope is not a strategy, and thus we plan for the worst. Okay, so how does this all tie in with DevOps? We are at a DevOps Day conference after all. So we like to think about this as class SRE implements DevOps. So if DevOps is this set of practices, guidelines, culture designed to break down silos, et cetera, site reliability engineering is a set of practices that we found to work, some beliefs that animate those practices, and a job role. So one of my colleagues has quipped it's sort of an opinionated implementation of DevOps to a certain degree. And again, the key areas of focus are actually the same. All right. So what is SRE at its core? Let's talk about what you could argue is the one key principle of site reliability engineering that the whole discipline is sort of built around. And that's this concept of error budgets. So to talk about error budgets, we need to talk for a moment about reliability and specifically how you actually go about measuring reliability. You could take a naive approach to this. So, availability is simply when things are good, the amount of time that things are good divided by the total time that you're measuring. So what amount of time is the fraction of time that your service is available and working? It's intuitive for humans. And it's easy enough to measure if you're looking at is the system up or is the system down, like a sort of a binary measurement. But if you're running a distributed system, it's a bit trickier. So what about the case where, is the server up or down if it's not currently getting requests? And then if one of 3 servers are down, is the service up or down? So there can be some ambiguity here. So we can talk about a slightly more sophisticated approach to measuring reliability. And this is simply looking at the number of good interactions divided by some total number of interactions with your system. So which fraction of your actual users experience your system as being available and working? So this actually works well if you're running a distributed system and enables those sort of slightly more ambiguous cases that we talked about on the last slide. So this just gives a picture. It's important to realize that it's not just about your system being hard down. There's more nuance here. We've got a list up here. If you're thinking about, it's really important to think about the amount of downtime that you're actually willing to tolerate for your system. We talk a lot about, are you running a 3.9 service, a 4.9 service, a 5.9 service? If you're running a 3.9 service, you're talking about less than 9 hours of downtime per year. And then if you're running a 5.9 service, so if that level of reliability is important to your users, you can only be down for 5 minutes a year. So there's big differences here in terms of cost and in terms of, like how you're meeting your user expectations. Okay, you'll notice that on that last slide, we talk about 3 nines, 4 nines, 5 nines. We never talk about 100% uptime, or 100% is the target. And Ben Trainer-Sloss, our VP of 24/7 engineering at Google and the founder of site reliability engineering at Google, he says 100% is the wrong reliability target for basically everything. It's pretty much an impossible target to achieve. And again, that's where error budgets come in. If you're not targeting 100%, what are you actually targeting? What's going to be an acceptable level of uptime for your users? So error budgets are basically an agreement between product management and site reliability engineering. So you define this availability target based on what your users are expecting. You take 100%, you subtract out that availability target, and there you have your budget of unreliability, or your error budget. Once you have this in place, and you've got monitoring in place to actually measure the actual uptime, you've got this control loop for understanding how you're utilizing that budget. So in a lot of ways, this is taking the emotion out of working between devs and SREs. The tension that's built in there. Okay, so once again, what are some of the benefits of using this particular concept? So error budgets provide a common incentive for both devs and site reliability engineers. So it's about finding that balance between innovation and reliability. And again, you're agreeing this in advance, so you're taking some of the emotion out of the conversation. Error budgets allow dev teams to actually manage risk for themselves, so they can decide how they want to spend that error budget. So is it on launching new features? Is it experimenting? How are they gonna do this? It also makes unrealistic reliability goals unattractive, because if the higher you set that bar, the lower your error budget, and then you're really dampening the velocity of innovation that's possible. Dev teams become self-policing, so the error budget is this valuable resource for them. Again, they can move as fast as they can up until the point that budget is exhausted, and then we really have to dial it back and focus on reliability. Error budgets also enforce this and really, make it clear that there's shared responsibility for system uptime. It's not just throw it over the fence to the operations team. We're working together to keep the system up and running at an appropriate level. All right, so talking about error budgets, it actually all boils down to three concepts. So we talk about SLIs, SLOs, and SLAs. SLIs are service level indicators. So this is how do you actually observe and measure that your system is, or that you're successful enough. The SLO is your service level objectives. So this is your top line target for the fraction of good interactions. So it's the goal, like is it a 3.9 service, is it a 4.9 service, like what are you aiming for? And then the SLA, or service level agreement, so this is about contracts, this is about what you're promising your users, and there can be consequences. So if you don't meet your SLA, then maybe you have to pay penalties or something. So typically SLA would be your SLO plus a bit of a buffer. Okay, so let's talk a little bit about SLO definition and measurement. Again, SLOs are a target for SLIs aggregated over time, and it's important that you're trying to exceed your SLO target, but not by too much, because if you exceed it by too much, you're leaving velocity on the table. And choosing an appropriate SLO can be quite complex, so it's useful to keep it simple from the start. Get something out there, get something documented to start the conversation, and then that can be evolved over time. So setting SLOs are important because, again, it sets priorities and constraints for SREs and devs, and sets user expectations about levels of service that they can expect. Some other questions to think about when you're defining your SLOs or considering SLOs. So where's your SLO document? How do you know that the SLO that you've set actually matches your customer expectations? How often do you review your SLO? Do you consider your SLO in your system design process? And then how do you actually measure SLO compliance? So good to kind of have these things in mind. Okay. So the great things about, service level objectives and SRE really help bridge the business development and operations, giving this set of stakeholders a common language. So unlike pure agile, which operates at the interface between business and development and operations, which is the traditional domain of DevOps. And if we look here, just talking about SLOs and error budgets, we've actually addressed 3 key areas of importance to DevOps. So, you've got the element of shared ownership, you've got error budgets, which acknowledges that failure is going to happen, and then you have ways to measure reliability. So again, you're making data-driven decisions and removing some of that emotion from the teams that are working together. All right, so let's move on now and talk a little bit about the practices of SRE. So SLOs and error budgets are sort of key principles, but then how do we actually defend that SLO and do that on a day-to-day basis? So we need to work on a few key areas of practice. So the key areas of practice for site reliability engineering, it's metrics and monitoring, capacity planning, change management, emergency response, and don't ever underestimate the cultural component to this as well. So monitoring and alerting. So monitoring is really your primary means of determining and maintaining reliability. How do you know if you're meeting your SLO if you don't have appropriate measures in place? Alerting, so when you're thinking about alerting, this is about triggering notifications when certain threshold conditions are met. So you'll get paged if there is a situation where immediate human response is required. So if your SLO is at risk, if you're about to burn your entire error budget, a page is appropriate to the person that's on call. A ticket would be, so an alert could generate a ticket, for example, if a human needs to take action, but immediacy is not critical in that particular case. And I think the other thing to point out here is you only want to involve humans when your SLO is threatened. So you shouldn't have humans, watching dashboards like a hawk, reading log files. So just to determine if the system's okay. Having appropriate monitoring and alerting solves for this, and you'll be alerted when bad things happen. Okay, so demand forecasting and capacity planning is an important element as well. So, public cloud scales infinitely in theory, but the cost associated with adding more resource to your service, your CFO might not be happy if you're like, just throw a bunch more machines at the problem. So it's important to actually understand, how much capacity do you need for your service, taking into account things like organic growth. So are you seeing increased product adoption and usage by your customers? Are you expecting any inorganic growth? So, seasonality, feature launches, marketing campaigns, et cetera, and what's that going to do to your service? And then it's important to be able to correlate the raw resources that you're using to run your service to that service capacity. So if you have, X amount of resources, how much QPS will that serve, et cetera. And you want to make sure that you have enough spare capacity to meet your reliability goals. Again, we can talk a little bit more about efficiency and performance. So as I was mentioning, extra capacity can be quite expensive. So you really want to run the gauntlet of utilization and optimizing your utilization. So resource use is typically a function of demands. So your load on your system, your capacity, your software efficiency, and SREs really, you need to have good prediction, good provisioning, and SREs need to be able to modify the software as needed. SREs also monitor utilization and performance, so if there is a regression, the SREs can act upon that. Less experienced teams might do this by throwing more resources at the problem. More mature teams or experienced teams might do this by, oh gee, this feature that we just launched or this thing that we've just launched is causing problems. Let's maybe roll back, figure out what's happening before we add more resources to the problem. Okay, so change management is also pretty critical to site reliability engineering practice. So at Google, we've actually found that about 70% of outages are due to changes made to a live system, whether it's a binary push, whether it's a configuration change, and change is basically a constant. I think where I work, where you work, change is unavoidable. So we're constantly making changes to our live system, so how do we actually manage this risk associated with change? So there's a few things. We think about mitigations, so canarying progressive rollouts to make sure that we don't just launch something with one big bang and terrible things happen. We also focus in on quickly and accurately detecting problems, so having good monitoring to minimize the mean time to detect a problem, and then having the ability to roll back changes safely when problems arise to help with mean time to resolve. And the other important thing here is if you remove humans from the loop with automation, this reduces errors, reduces fatigue, and actually can improve velocity. In a lot of ways, machines can react a lot faster than a human can, and can actually impact those time to resolve type of metrics. Okay, so we've talked a little bit already about how 100% is basically the wrong reliability target for anything. You want to determine this desired reliability for your product, and then don't try and provide better quality than that's desired or expected by your users, or that your users will even notice. And again, the goal here is not to go slow, but to go as fast as possible given the error budget that we have. So you go as fast as possible until you exhaust that error budget, and then you turn inward to look back at the reliability. So the goal is to increase development velocity, and not to have zero outages, but to achieve that maximum velocity within that particular budget. So again, devs can decide to use that error budget for releases, experiments, whatever they think is going to give them the most bang for the buck. Okay, so what about when things go wrong? The other fourth key area of responsibility for site reliability engineers is this emergency response and incident management function. So what happens when things break? So things break, that's life. It's just a matter of when and how serious it's going to be when it does break. It is important to note that people don't necessarily react well to emergencies. It can be a pretty stressful time. So first of all, focusing in on don't panic. You're not alone. People are not going to die if your software goes down, at least not most likely. Unless you're in the healthcare industry, maybe. Aviation. There's a few examples here. But what you want to do here then is figure out, you've got to mitigate, troubleshoot, and fix the issue. And don't be afraid to ask for help. I think that's a key element here as well. And again, since incident response can be very, very stressful, it's actually important to put well-defined processes in place and to practice these before you hit a real situation. It adds confidence. It helps you stay calm in an emergency, and be able to focus on getting your service back up and running. And then once that's done, like once you've sort of solved the initial issue, taking some time afterwards to make sure that the problem doesn't happen again. All right, so let's talk a little bit more about incident and postmortem thresholds. So one of the issues that often comes up is people don't pull in help when they need it. So don't ask for help, or just like, I got this, I'm going to be the hero, I'm going to solve this issue. But I think one of the things you can do to help guard against this is to define incident thresholds. So at what point do you declare an incident and therefore make additional resources available to help with the problem, to bring in other responders to help? And some thresholds you might consider are, if there's user visible downtime or a degradation beyond some specified threshold, data loss of any kind, if the on-call engineer has made any sort of significant intervention, or if there's a resolution time above some threshold. But defining this in advance before an incident starts is really important to take the guesswork out of the situation. And oftentimes these thresholds are tied to how much damage are you doing to your SLO, how much damage are you doing to your error budgets. If your SLO isn't at risk, no big deal. If it is, you want to get in there and put more resources on the problem. Okay. So now let's talk a little bit about postmortem philosophy. So whenever there's an incident, you're paying a price. There's something has gone wrong. You've paid the price. A postmortem is the gift that you give to yourself. It's the gift that you give to yourself to ensure that you learn from what happened and do what you can to make sure that the incident doesn't happen again. So you want to make sure the incident's documented, that the root causes are well understood, and effective preventative measures are put in place to prevent that likelihood of reoccurrence. And writing a postmortem is not meant to be a punishment. It's just something that's expected and can be quite helpful after a bad event. I can't underestimate the importance of blamelessness in this process and as a key component of site reliability engineering culture. So postmortems need to focus on identifying contributing causes, but not pointing fingers at people or at teams. Humans are never the cause of incidents. It's all about what was it about the system that allowed the human to do the thing that, fat finger something and it went wrong. So blameless postmortem assumes everyone involved has good intentions. Human errors are really system errors, so you can't fix people, but you can fix systems to make it easier to do the right thing, harder to do the wrong thing. And if this culture of finger pointing prevails, people are not going to bring issues forward. They're going to sweep things under the rug if they're worried about their coworkers coming after them with pitchforks or losing their job because they did something wrong. And that's just makes your systems more brittle and is bad for everyone. All right, I got to crank through because I'm running out of time. But toil management, I want to say a few words about that. So operational work is important for site reliability engineers because you get experience with real failures. It's the wisdom of operations. You can't automate everything, but if you do enough ops work, you know where the big wins are in terms of your automation. Toil is, we consider that work that's manual, repetitive, things that can be automated, that are tactical, without enduring value, or that grow with the size of your service. So effectively, you're feeding blood to the machines. And in site reliability engineering at Google, we cap this toil and operational work at 50% of the engineer's time. Operational work is important, but if you're doing more than 50%, you're not an SRE. And I did want to mention that empowering SREs is super critical. So there needs to be this organizational buy-in, or stuff, it just doesn't work. So SREs must be empowered to enforce the error budget and toil limits. At Google, at least, SREs are about 10% of the overall engineering population, so only the most important services have SRE support, so you want to use their resources wisely. And then we don't want SREs to take on too much of an operational burden, allow them to load shed or hand back the pager to developers if the system needs additional work. All right, so to recap, metrics and monitoring, capacity planning, change management, emergency response, and these cultural elements are critical to SRE practice. We've talked about how SRE implements the 5 key areas of DevOps. So when you factor in, layer on the automation, layer on the blameless postmortems, we've now got these 5 key areas covered. Super quickly, how to get started. If you want to embark on this journey, the first thing you can do is start with service level objectives. So put an SLO and an error budget in place, and then iterate from there. Hire people who write software. Like I said, we joke that we hire lazy engineers, so people that get quickly bored by doing the same things over and over again. You really need to work as an organization to ensure parity of respect with the rest of the development and engineering organization. And again, provide that feedback loop of self-regulation so that the SRE teams choose their work, and they must be able to load shed if their ops load gets too high. Start small, canary it, go from there. And then once you've done that, once you have some success that you can point to and some data that you can point to, spread the love. And to conclude, I just wanted to highlight, if you're interested in learning more on this subject, we've written a couple of books about site reliability engineering. The first book was written back in 2016 and talks about foundational principles, practices, and culture of the discipline. Google also published the Site Reliability Workbook, which talks about more practical examples of how to implement SRE concepts. And then Seeking SRE is more of an industry-wide review of site reliability engineering practices. Google.com/SRE has the full text of the original book. The second book will be coming out in January, I believe. And there's lots of other interesting resources there as well. And with that, I'm out. Thanks, folks.